Presentation entitled the DWPT Project, the Experiment Development of Innovative Technology Towards the Decarbonization of Transportation System, concerns about the development of innovative projects focused on the decarbonization of transportation system. Before I begin to describe the various arguments, let me contextualize why it is becoming more and more urgent to change the pollution that we are creating through human activity. In this slide, I have included a photograph of one of the Emilia-Romagna towns affected by the that occurred this spring, and it lasted more than a month. In recent years, destructive meteoric events are becoming more and more intense, and their duration is increasing. This is a clear warning to intervene with a radical change in our habits. The presentation will be divided into 5 sections. It will start with a brief introduction and framework of the topics that concern the development of the electric road system. I will continue with the lines of experimentation divided into the research experience on site and in the laboratory. The penultimate section will concern the innovations introduced in today's second cycle flooring. It will therefore end with the conclusion section and the new goals set to continue the research activity. Nowadays, it's common to hearing experts talk about the pollution that is ruining the ecosystem of our planet. Pollution is mainly due to our anthropic activities that causes a high CO2 production, and for our habits that often see the use of disposable products and a high consumption of plastic. On the other hand, on the right of this slide, you can observe some of the solutions we are trying to achieve. For example, sustainable form of energy such as photovoltaics or wind turbines, and the conversion of automotive engines from combustion to electric or hybrid, and more the design of a smart city to control pollution levels and energy consumption. In our file, we have a duty to develop environmentally sustainable type of transport to support and protect our planet for future generations. So this is mean eco-sustainability. In this lies three types of vehicle engine operation when compared. The DWPT system and the plug-in technology are both systems in which the vehicle has an electric motor. The difference is made by the type of battery and especially its charging. Instead, the comparison with the combustion vehicle is definitely the reduction in emission for both vehicle operation and fuel production. In the DWPT system, the charging of vehicle battery takes place during its direction of travel and without any contact, using the physical principle of induction, so no times and place to stop. Going deeper on the DWPT system, we can call it like an hidden infrastructure. We don't see it as it is covered by the pavement. Its operation is based on the physical principle of the magnetic oscillating field. In fact, we can understand it by taking the example of our rechargeable smartphone with wireless systems. How does it work? Both the recharging device, the source recharging plate of the cell phone, in our case the DWPT system, and the device which must be loaded possess within the electromagnetic coils. Specifically, the DWPT system is composed of energy converters and passive elements, including the magnetic device that communicates with the receiving device, which is precisely the coil contained in the vehicle battery. Obviously, the direct gain for the users is the travel autonomy and the saving of time lost for charging, and for the society, the reappropriation of urban space now taken out for parking dedicated to recharging electric vehicles. Slides are reported a comparison about the existing technology of electric roads. On the left is presented the aerial charging cables for electric trucks or overhead contact line. This system is born in Germany and is being particularly researched in the UK with the powerful collaboration of Siemens and Scania. Unlike cars, which remain parked and stationary for most of the day, trucks are used for long hours in transport assessment, when stopping to recharge can be very disruptive operation. Obviously, to the height of which the system is set up, it is unusable for vehicles. In the middle, we can observe the ground lever power supply. This technology was developed by collaboration between France and Sweden. In both countries, pilot road sections were built for research purposes. It concerned placing a double track in the middle of the road made up of 50-meter section, so the truck with a contact device received the energy. Like in the previous case, the system is difficult to use for all vehicles and leaves operating difficulties in doing maneuvers, such as overtaking. On the right is presented the DWPT system in a testing phase. That will be described in the following slide. The slide shows that the system is currently being studied for vehicles involving road transport, but may be extendable to any class of transportation, such as even trains. The problem will then become finding alternative and environmentally sustainable form of energy to be able to sustain demand. The main focus of this presentation will be the illustration of the two guidelines of experimentation followed for the development of the research. Each of the two lines was complementary to the development of the other and of the system as a whole. One is on-site, which sees the construction of a test track 1 kilometer long and composed of different cross-sections for the study of behavior of the pavement applied to different urban and extra-urban contexts. The other, instead carried out on a controlled scale in the laboratory, has made it possible to solve and develop complex problems with an evident economic advantage and speed of analysis. It also made it possible to develop an aging model of materials subjected to the inductive load generated by the DWPT system and to study multiple additives simultaneously. Start showing the research conducted off-site. The electromagnetic flux generated by the coil was analyzed both from the point of view of the efficiency of the electrical infrastructure and for the exposure to which the users are subjected when they are on board of the electric vehicles powered by the DWPT system. In the pictures above, you can observe an electromagnetic flux capture device of a shape of a microphone positioned in the cabin of the prototype bus used for the on-site testing. The device was placed in the position of a standing and set-up passenger and on the floor of the cabin. Other devices were instead used for the detection and control of the electrical infrastructure by the management unit and the cabling cabin for the electrical power supply. The data is acquired thanks to continuous measuring device. Calculate the efficiency of the system which they reaches the 92%. It was decided to fix 80 meter straight section inside the circuit. The prototype vehicles, which are a Fiat 500 and vehicles intercity bus, arrive the straight section in acceleration, then move to a constant average speed and end the section in deceleration. The consumed and the stored energy values are obtained as an average. Further characterization tests and parameters monitored on-site are obtained through tests performed with the falling weight deflectometer for the formation under load and mechanical parameters of the materials in the various layers of the pavement. The optic fiber was then installed for monitoring the temperature in correlation to the electromagnetic flux generated during the operation of the coils, and the mechanical characterization continues with tests of a destructive nature in the laboratory. The tests are performed on core taken along the circuit every 4 months. I will now illustrate the steps followed on the laboratory experimentation. The goal was to perfectly perform the electrical infrastructure present on the circuit on a small laboratory scale, in order to generate the same frequency and intensity of the sinusoidal flux. The following instrumentation was used. Starting from the power supply, the energy arises as a signal generator which communicates directly with the coil controller for the calibration of the pre-stabilized flow parameters. At this point, the signal is transmitted in pulses thanks to a signal alternator and then passing through the turns of the coils. In the center of this slide, there is a picture showing a section of the road package with the bins in which the coil and wiring are located. The colored lines shown indicate the levels of which the floor will be mounted, useful for positioning the sample of material that will be subjected to aging due to the inductive load during the experimentation. On the right and on the left, there are pictures illustrating the preparation phases of the floors. They are made with amagnetic materials to avoid creating disturbance interference with the electromagnetic field generated. Another expedient was used by choosing plasterboard. It is known as a fireproof material in case of overheating of the coil and possible fire. Each sensor will be so installed for each floor to capture the electromagnetic flux and the sensor to record the temperature. Four temperature sensors will be installed in the test environment room. The electromagnetic apparatus for laboratory experimentation and data acquisition for parameter processing, and with the wiring of the sensor to the data acquisition card, which in this turn is connected to a computer. For reason time, we'll focus only on the welded circuit components on the 1000-hole card, so you have to see the dark yellow arrow and dot that are necessary to register the peak of the sinusoidal wave. Laboratory experimentation have the objective of bringing results and solutions in the fastest possible time. For this reason, the coil is kept active for 24 hours a day during the trial period. On the right, there is an explanatory video of the type of impulse signal generated by the coil. You can observe how the signal switches off once it has reached the peak of the wave sinusoid. As I have announced at the beginning, the experimentation on the real and laboratory side is enriched by the comparative analysis of the results achieved by the two scales. Currently, in the literature, it hypothesizes that the deterioration of a road pavement subjected to an inductive load is due to the stripping and puckering of the chemical bonds of bitumen, similarly to what happens for the oxidation of the bitumen due to the exposure to UV radiation. Therefore, with the execution of rheological and chemical analysis, we have set the goal of achieving a calculation model to forecasting the evaluation of the aging of the bitumen subjected to the electromagnetic flux. Before I present my conclusion, I would like to present one of the contributions provided by the laboratory activity and contribute to the growth of on-site experimentation. With the laying of the second cycle flooring for the circuit, we have achieved one of our objectives set last year. Thus, we have created a solution capacity with the use of the 31st stage of level to date on the plans in the So to conclude, I show you the timeline of the activities performed since the birth of the DWPT project in 2021. The main goal remains, as from the beginning, the strengthening of laboratory activities to which will be added life cycle assessment analysis for the evaluation of the electric road system. Obviously, this project is the result of the collaboration of various companies and professionals. The main ones are Brebevi Motorway Company, Mapei for Materials, Electron for Coils, and others that I have summarized in this slide. I am really grateful for your attention. Here you can find my contacts, and I remain at your disposal for any question or clarification.